Okay, so for today, we're going to do part two of some definitions for you. All right, the first definition we're talking about is requirements. So a requirement is something that your task, your technology, or whatever has to do, right? Has to do. Now, there's some different types of requirements. So one requirement could be a performance thing. So a performance type thing is how it does something. So it would identify skin lesions. It will identify something. Should be able to measure something. So this is can do. Does that make sense? So you need to make some engineering that can do something. So that's its performance. Its performance is about what it can do. Same thing as functionality. They're just synonyms of each other. Another type of requirement could be reliability. Okay, so this is how often. All right, so it might be operational 99.9% of the time, so it has to work for long periods of time. Could have to have a lifespan of 10 years. Okay, it could have to be accurate, or it could have to fail in a certain way so it doesn't cause problems. Anyways, this is reliability, so how often it does. Another type of thing is energy. So this is, in some ways, how expensive. All right, how expensive to run. Average power consumption of 2 watts. Peak current draw of 1 amp. So how expensive, how much energy it does. Okay, so it could talk about, and then there's other requirements too. For example, you could have a weight requirement where you have to have it under a certain thing. You could have a size requirement. You have to make it smaller than 3 feet tall. There's an unlimited number of these, but here's some examples. So the main thing to take away here is a requirement is what it has to do, what the goal of the technology, the invention is. Another thing is a constraint. A constraint is like a rule, okay? It's something that's holding you back. So you could have an economic constraint. Now, what an economic constraint means is that you only have so much money, okay? So if I told you I need you to invent a new machine that will fold laundry that can go next to the dryer, you would have a limitation for economics because you don't have enough money to sink into this thing. You'll have to use other resources. All right, another thing is environmental. What do you think environmental is talking about? That's right, you cannot damage the environment in severe ways. So this might not apply to your laundry folder invention, but this might apply to other things that produce a harmful chemical. Okay, maybe it burns carbon, burns fossil fuels, so it produces carbon dioxide, and that could cause environmental problems. All right, ethical and legal. So slightly different words, but same general meaning here. It's got to be legal. It's got to follow the rules. Okay, so you can't make something that wouldn't be legal. Well, you wouldn't want to. It wouldn't be profitable. And with that in mind, you want to follow the rules of ethics as well as an engineer. Okay, just because it's legal doesn't mean you should do it. All right, so you got to follow rules. Health and safety, so it has to be safe, right? It has to be safe. So that is something that slows you down. If you make it and the workers are all getting destroyed, that would be bad, and that would be harming safety and health. So health is more referring to a long-term effect. In the coal mines, they had lots of lung problems, for example. That'd be more of a health than a safety thing, but it's the same idea. Manufacturability. This is talking about, is it buildable. So can it actually be built? So it's a constraint because if you make it one time, but it's not really practical to mass produce, that's going to affect your profitability here. Political and social. So will it have political and social ramifications? All right, so like the FDA, for example, there's lots of talk about them right now, but will there be problems from politics, right? So that is something that could hold you back. Maybe the politics of the situation wouldn't lead to a very useful profitability margin for your invention. And the last one, sustainability. So sustainability is talking about, will it last? So you have to make it so it doesn't just peter out in a day or so, depending on what your invention is. Your laundry folder wouldn't be very good if it only worked once. All right. So these are your constraints. There are others, but these are some examples to help us understand. So now we're talking about 7 key resources that we're talking about here. All right, the first one, and arguably the most important one, is people. So people are the workers. All right, so if you have a company, we'll say, and we're inventing it, you might have people working for you. They are a resource that you can use to help your company become better. If it is just you, well, you have a person working for it. You also have energy. You have electricity or whatever else it is using, chemical, there's chemical energy, all that kind of stuff. Let's just write electricity. So you could have electricity. If you don't have energy, well, you're going to have a tough time. Capital. Capital. What's capital talking about? Capital is talking about money. So you could have a certain amount of money. If you have more money, it's going to be easier for your company to do better. You could have information, right? So this is how much you know. The more you know about something, the more of a resource you are, right? Tools and machines, right? This is tools and machines, anything that helps your people just working. So you could have something to measure, something to, wrenches, pliers. You could even have large machinery like chainsaws or whatever, depending on whatever you're doing. Materials, if you have materials, this is just raw materials, right? Let's say you have some scrap metal for your laundry folder or whatever. And the last one is time. Time is important because you can use it. So, I don't know. Time. I think you understand what time is. If your company doesn't have any time, well, it's not going to be very profitable. So these are 7 key resources here. You need all of these in some measure to be successful in engineering and in life in general. But the more of them you have, the better off you'll be. Now, you can always substitute one for the other in a way. If you don't have any materials, you can spend some capital to cover for that because you can buy the materials. So this is where your opportunities come from, by using these things. So technology. Technology is a little different than engineering. Technology is the means on which we humans modify the world. So technology helps us to modify the world for our wants and needs. For example, right now you are watching this at home. You want to learn, or at least you need to by government decree, and this situation has been modified so you can watch this at home instead of showing up to school. This involves an artifact. An artifact could be whatever object it is. It could be your phone, it could be your TV, it could be something not electronic. So something you need to know is it does not need to be electronic. So it could be a spoon or your shoes. Maybe there's that new type of shoes that has fancy stuff in it that's not electronic and helps you run fast. Vroom. Okay, it could even include other things like the kernel of grass, grains we use in our cereal. So it could be some organic thing. So you figured out how to harvest this from nature and use that. So that'd be something you can use too. Technology often involves a system, right? Because it's been developed, it's been worked. It includes the people, infrastructure, and the process. So all together, all the process together. All right, so if we're talking about the phone, right? There was a process to put the phone together, and that would be involved in the technology. So the design, the manufacture, the use, and the repair, all of that would be together here. The innovation, change, or modification are of the nature of the environment to satisfy human needs or wants. Right, so this would also include the changing of the environment, the modification of the environment to satisfy human innovation in action that involves the generation of knowledge and process to solve problems and extend human capabilities. Nice. So we're about solving the problems and extending human capabilities. That's what technology is helping us to do. Now we're going to talk about a different word. It is science. So science involves knowledge about the natural world. It's different than technology, all right? Because for science, knowledge for its own sake. You want to know this? Why? Because you want to know it. So discovers and explains what it is. So it's about discovering things to discover other things, right? Engineering involves creating what has never been. So engineering is more about creating things and designing things that are useful, whereas science is more about knowing things and knowing more things. All right, that's the main difference between them that we're going to understand. So here's an example here. Technological progress will promote science advancement, all right? So if there's some new piece of tech, what it will do is it will help science, and science will make more discoveries. And then what science will do is science will lead to some more technology because now we'll know about these things. And then what that will do is that will lead to some more science. So it's going to be a vicious cycle here. So it's going to go back and forth and back and forth, and they're going to get better every time. So here's an example. Here's a mass spectrometer. So a mass spectrometer is used in lots of stuff here. So you've got a sample. Here's a bunch of atoms. They shoot through here. They're ionized, so they have a charge. They go through. They have a magnet here. And the magnet turns the particles, and then they go over here. Now, the problem is the heavier stuff doesn't corner quite as well. So the heavier stuff hits the wall here. The lighter stuff hits the wall here. And so the ones that are just right make the turn. Now, this is a piece of technology. However, this piece of technology helped science by isolating certain isotopes of atoms here. So that allowed them to study atoms in isolation, which is going to improve technology. So what they're going to do with that is they're going to make improved medicines, improved computer science, because they're able to isolate the atoms to make different, better microchips. All right, a scientific process. This should be something you're familiar with. You ask a question, do research, hypothesis, test, analyze results. And then if it's true or false, you're going to report your result, and then you can go back and modify your hypothesis. This should be something you are more familiar with. There is also an engineering process. It's generally the same, but it looks a little different. So the first thing we're going to talk about here is the first thing we have to do is we have to understand the problem, right? Just like before, what are the requirements? What are the constraints? What do they want here? Okay, so that's for here. So we need to ask the question. What is the question? Then we need to brainstorm and design. So we're going to imagine, we're going to be creative, we're going to investigate things, we're going to figure it out. Once we have some ideas, we're going to pick the best one and we're going to plan with that. So that's where planning comes in. How will you test your plan? What will it look like? All right, once you have a plan, then we're going to create your plan. Once we have a creation over here, then you're going to improve it. You're going to work with it to make it better. So there's your engineering plan. Once you have that, you could always go back to make it the best way. You ask how to improve it, you imagine how to improve it, so it's going to be continuously traveling all the way around. So fun. Nice. All right. Hey, so check out these fun places for more. Like and subscribe.